In 1823, a German astronomer named Heinrich Olbers looked up at the night sky and noticed it was dark. He wondered why, because if the universe were infinite and stayed the same forever, the night sky should be full of stars, shining brightly. This idea became known as Olbers' paradox, and many thought it showed that the universe had a limit. But about 100 years later, Edwin Hubble discovered that the universe is actually expanding, which solved the mystery. Olbers was wrong about the universe being still. But what does modern science say about the size of the universe now? Is it finite with an edge somewhere? Or could it go on forever, stretching endlessly into space? This is a question that fascinates both children and scientists alike. Let's explore how big the universe really is and what it might mean. Early discoveries about the universe. The study of the cosmos often makes us realize how small and insignificant we are compared to the vast universe. Long ago, people believed the Earth, Sun, and Moon were the center of everything. But today, we know the universe is far bigger than we can even imagine. Over time, as science has progressed, we've had to accept that our place in the universe is not as important as we once thought. This shift in thinking began in the 16th century when scientists like Copernicus and Kepler proved that the Earth isn't the center of the universe. It's just one of many planets. Later, in 1838, Friedrich Bessel used a technique called parallax to measure the distance to a star named 61 Cygni. It was over 10 light-years away, around 100 trillion kilometers, which was mind-blowing at the time. Then, in 1920, two astronomers, Harlow Shapley and Heber Curtis, debated whether distant nebulae were small clouds inside our galaxy or actually separate galaxies far away. Edwin Hubble later proved that these nebulae were indeed other galaxies, like Andromeda, which is 2.5 million light-years away from us. Today, with much better telescopes, astronomers can observe objects far beyond what early scientists could even dream of. One of the most amazing discoveries is a galaxy called GNZ 11. The light from this galaxy took 13.4 billion years to reach us. This means we are seeing it as it looked when the universe was only a few 100 million years old. If we could see GNZ 11 as it is today, it would likely look very different, or might have merged with other galaxies. The observable universe and its limits. The current distance of GNZ 11 from Earth is estimated to be 32 billion light-years. This might seem confusing because the light took 13.4 billion years to get here, but we have to remember that the universe has been expanding all this time, so the galaxy is now much farther away than when the light left it. Galaxies like GNZ 11 help us understand the minimum size of the universe, but since the universe is 13.8 billion years old, there could be even older and more distant objects out there, meaning the universe might be bigger than we think. At this point, it's important to understand the difference between two terms, the visible universe and the observable universe. These terms don't depend on the power of telescopes, but on the limitations of space-time itself. The observable universe is the distance to the farthest object whose light could reach us since the beginning of time. However, there were no stars or galaxies in the very early universe, so we can't actually see anything from that time. Based on current calculations, the edge of the observable universe is around 45 billion light-years away. Anything beyond this is impossible to see because its light hasn't had enough time to reach us yet. We call this limit the particle horizon, like the horizon on the ocean that blocks our view of anything beyond. The visible universe is slightly smaller than the observable universe. For the first few 100,000 years after the Big Bang, the universe was so hot and full of charged particles that light couldn't travel freely, similar to how fog blocks your view. Only after the universe cooled down did light become able to move freely. So the visible universe is about 1 billion light-years smaller than the observable universe. The size of the universe is so vast that it's almost impossible for us to truly grasp. When we talk about the observable universe being 45 billion light-years away, we need to be careful. Some explanations suggest doubling that number to get the diameter, but things might not be that simple. Imagine if the universe is curved, like the surface of a sphere. In that case, you could see the same galaxies from different directions, just like if you looked around a globe and saw the same point from opposite sides. If this were true, the universe might not be as large as we think. It could actually wrap around itself. To explore this, we can look at the cosmic microwave background, CMB. The CMB is the oldest light in the universe, dating back to when the universe was only 380,000 years old. It fills the sky in all directions, carrying information about the early universe's temperature. Scientists study it closely, looking for repeated patterns that could suggest the universe loops back on itself. If we saw these patterns separated by large distances, it might indicate that the universe is smaller and connected in strange ways. However, detailed studies of the CMB show no such repeating structures, which tells us the universe is at least as big as the observable part. Shape and curvature of the universe. Now imagine someone living in the galaxy GNZ11. If they looked back at us, they would see the Milky Way as a faint galaxy in the distance. But if they looked in the other direction, would they see an edge or boundary to the universe? We don't really know. A key idea in astronomy, called the cosmological principle, assumes that no part of the universe is special. What we see from Earth is probably typical, and if someone lived at the edge of the observable universe, they would see another observable universe around them, just like we do. This idea suggests that the full universe could be at least 180 billion light-years across if we imagine stacking these observable universes. But we still have to be cautious because the universe could wrap around in such a way that it seems infinite to us, even though it might not be. To explain this with a simple example, imagine that at the edge of the observable universe in one direction, there's someone named Alice. She looks out and sees another person, Carlos, at the very edge of her view. Now, if we look in the opposite direction from Earth, we might see someone named Bob. Bob too looks out and sees Carlos. Alice and Bob can't communicate with each other because they are beyond each other's horizons, but they are both seeing the same person, Carlos. This would mean the universe repeats itself, but no one knows because there's no way to connect these observations. When we talk about the size and shape of the universe, curvature becomes important in understanding its true nature. On Earth, we don't directly notice the planet's curvature because it's so large. However, just like Eratosthenes of Cyrene figured out Earth's curvature by using shadows of sticks in different locations, astronomers use the cosmic microwave background, CMB, and geometry to measure the curvature of the universe itself. Imagine you have two parallel lines. On a flat surface, like a table, they will stay parallel forever. On a positively curved surface, like a sphere, the lines will eventually meet, like when you walk straight north on Earth, you'll meet someone else at the North Pole. On a negatively curved surface, like a saddle, the lines will keep moving apart. So, how curved is our universe? Scientists measure this curvature with something called the curvature parameter, or omega k. In 2000, the boomerang experiment showed that the universe was flat within 6% accuracy. Years later, the Planck mission refined this estimate, showing that the universe is flat to within 0.19%. This is a huge achievement, giving us an incredibly precise understanding of our universe's shape. Infinity, purpose, and meaning. But what does this flatness mean? Many people assume that if the universe is flat, it must be infinite. While it's possible the universe is infinite, flatness doesn't automatically mean that. In fact, a flat universe can still be finite. Here's an example. Imagine our universe is like a two-dimensional sheet of paper. Now let's say we travel in one direction, past Alice, Bob, and Carlos, and eventually we end up back where we started, just like in some old video games like Pac-Man or Asteroids, where the left side of the screen connects to the right side. This wrapping around of space means that while the surface may seem flat, it still loops back on itself. This kind of space is called a two-cylinder. You can think of it as a flat sheet that wraps around into a cylinder, meaning we could keep traveling in one direction forever and return to where we started. But this two-cylinder doesn't solve the problem of infinity because its length goes on forever. Now imagine we add another rule. If you go past the top edge, you reappear at the bottom, like Pac-Man moving vertically. This new rule creates a shape called a two-torus, which is like a donut. In this scenario, the universe doesn't extend infinitely in any direction because both the horizontal and vertical directions loop back on themselves. So even though the surface is flat in a fundamental way, it wraps around in both directions, creating a finite space, just like the surface of a donut. This shows that a flat universe doesn't have to be infinite. It could still be finite, like this torus, wrapping around itself in such a way that there's no edge. But it also doesn't go on forever. Let's talk about a brilliant mathematician named John Nash, who was famously portrayed in the movie A Beautiful Mind. Nash made a discovery that relates to our discussion about the shape of the universe, particularly the two-torus donut shape idea. Normally, when we try to wrap a flat surface into a torus shape, we stretch and distort it, which means we don't preserve distances properly. But Nash proved that you can, in fact, keep distances correct, or isometrically embed the shape, by adding lots of tiny wavy distortions along the surface. This was an amazing mathematical proof. Then, in 2012, a French team used powerful computers to figure out exactly what this embedded torus looks like. And yes, It still follows the same rules of a flat universe in the fundamental sense. But here's where things get more complicated. What if the universe is infinite? Instead of being finite like the torus, the universe could be a flat plane that goes on forever, or it might be a negatively curved saddle shape, also infinite. Either way, we're left with a challenging idea: an infinite universe. Infinities are uncomfortable for physicists because they lead to strange consequences. If the universe is infinite, then everything that can happen will happen, not just once, but an infinite number of times. That means there are infinite versions of you, living out every possible variation of your life, down to the tiniest detail. This idea can be hard to wrap our minds around because it implies that somewhere, an exact copy of you exists, sharing every single molecule, atom, and even quantum state. Some scientists have proposed theories like eternal inflation to explain this. In this model, our universe is just one bubble in a vast, infinite space, where each bubble has different physical laws. However, even this theory doesn't fully escape the idea of infinity. It just pushes it further out. If we accept the possibility of an infinite universe, it leads to mind-boggling consequences. There could be an infinite number of Earths, each with an infinite number of you, living in an exact copy of our universe, down to every atom and every quantum particle. This idea challenges not only physics, but also how we think about our own identity. If these copies of you are identical in every way, are they truly different people, or are they just other versions of you? This concept even brushes against the no-cloning theorem in quantum mechanics, which says you can't create an exact copy of a quantum state. But in an infinite universe, these duplicates would exist naturally. Each one would be living their life, watching this very same explanation and pondering the same deep questions about existence, just like you are now. It's a fascinating but unsettling idea that forces us to rethink our place in the cosmos. This unsettling idea goes even further. Not only are there infinite doppelgangers of you, there are versions of you spread out in time, one day behind or 2 weeks ahead. You exist everywhere, and you never truly cease to be. It's an overwhelming thought, but it also brings a strange kind of comfort. For those we've lost, they too continue to exist somewhere, in infinite variations. In some version of reality, our loved ones never faced that tragic accident, never took those terrible steps. They're still out there, in an unimaginably distant part of the infinite universe, living different versions of their lives. However, this infinity can also feel strangely empty. If the universe goes on forever, it can make our goals seem insignificant. If we define our purpose by reducing suffering, how can we succeed in a universe where suffering is infinite? And no matter how much happiness we try to create, it would seem like a drop in an infinite ocean. The very concept of infinity makes it seem as though everything we do might be futile. But maybe, instead of looking outward into this infinite, indifferent universe, the real meaning lies much closer, within ourselves. While there may be an infinite number of versions of you, only you can control what you do today. How you choose to live your life, how you treat others, that's where meaning comes from. In an infinite universe, even the smallest act of kindness has infinite value. Perhaps in this vast cosmos, the choices we make in our daily lives are the only things that truly matter. The universe is vast, and its mysteries can sometimes feel overwhelming. From the smallest acts of kindness to the grandest cosmic questions, we all play a part in the story of existence. So while the universe may seem infinite, only God knows how big is universe. What do you think about the universe? Comment below.